We are constantly told that the future of artificial intelligence requires massive supercomputers, gigantic data centers, and a constant, flawless connection to the internet or the cloud. But what if everything we know about scaling AI is completely wrong? Imagine a device making complex, real-time decisions completely offline. Recently, MIT engineers led by Associate Professor Jeehwan shattered the limits of modern computing. They designed a brain-on-a-chip smaller than a single piece of confetti. But this isn't a normal microchip. It is packed with tens of thousands of artificial brain synapses known as memristors. It doesn't just calculate. It mimics the exact physical architecture of the human brain. To understand why this is a revolution, you have to look at traditional computers. Standard circuits use conventional transistors. They transmit information by switching between only two binary values, 0 and 1. It's a rigid, digital system. But a memristor works differently. It works along a gradient, just like a biological synapse inside your head. It can remember the exact value of an electric current and reproduce the same signal over and over. However, earlier versions of memristors had a fatal flaw. To make these chips energy efficient, the conduction channels had to be microscopic. When a weak voltage was applied, the ions, the tiny particles carrying the signal, would literally wander off. They would disband and get lost inside the medium. The circuit would fail, and the memory would be wiped out. This is where the MIT team stopped thinking like traditional computer scientists and started thinking like metallurgists. Instead of just trying to push more electricity through a broken system, they decided to tweak the atomic interactions themselves. They needed a positive electrode and a negative electrode. They used silicon for the negative side and silver for the positive. But silver ions alone were unstable. They needed a bridge. After intense research, they landed on the perfect alloying element, copper. By combining silver, copper, and silicon, they created a metallurgical masterpiece. The copper acted as a microscopic anchor, stabilizing the silver-silicon interface. It held the silver ions together tightly, forcing them to flow quickly and perfectly in a straight line, without a single ion wandering off. With this new copper-silver alloy, the team put their confetti-sized brain to the test. They asked the chip to recreate a highly complex, grayscale image of Captain America's shield. They equated every single pixel of the image to a corresponding memristor. The chip didn't just render the image flawlessly, it remembered it. It reproduced the exact same crisp, clean image multiple times, far outperforming any existing technology. They even programmed it to sharpen and blur images of MIT's Killian Court, doing real inference tests without a supercomputer. This isn't just a lab experiment. This is the foundation for portable AI. Soon, a camera on your car could recognize objects, analyze danger, and make life-saving decisions instantly, completely on-site, with zero internet connection. We are stepping into an era where our devices will think exactly the way we do. You can read the full, mind-bending paper published in Nature Nanotechnology through the link in the description. If you want to stay ahead of the technology curve, hit subscribe. We'll see you in the next breakdown.